Hi, today I will be letting you know regarding a feature called evaluate. Okay, so let's start making a part. Okay, front plane. We'll make a very simple part as usual, by drawing a rectangle somewhat bigger. That's okay, and make it okay. Now this is the box which is ready. We don't know any dimension about this box. Okay, we'll directly go to this option, evaluate over here, left click, and as you can see, you know there are many options here, like the measure, the mass properties, the statistics, the deviation analysis, many options. So out of which we will start the first option. I want to measure the part. Now what I want to measure in the part, first you need to understand what is evaluate. Like whenever anything is ready, you are evaluating with different features, like how the part is, what are the dimensions, what can be done with the part, and in what conditions, what is going to happen with the part. So everything related to this part, the different measurements, the different processes, the different uh, statistics, everything. So this is what evaluate is. You are just evaluating the part. You are not changing anything, you are not modifying anything, you are not increasing or decreasing anything, just evaluating, or you can say in simple words, checking the parts or testing the parts. That's it. So that's the evaluate, checking and testing. Okay, we'll start with the first option for measure. Left click. When you measure, a box opens. Okay, and our pointer changes to such thing, like you can see this is our pointer, and it shows some kind of scale and a small box, a tape kind of structure. Okay, and this is selected XYZ, show XYZ measurements. Now I want to measure, what I want to measure is point, distance between 2 points. So click here, 1 point, and click here, 2 points. Look, it shows the distance between these 2 points is 87.78 millimeter. We used to work in smart dimensions, and what happened is, like, when you used to work in smart dimension, it used to give us the dimensions or the angles and everything. This is very similar, but it is much more simpler, and I'll show you what difference it has with the smart dimensions. This is measurement on the feature and not on the sketches. Okay, so now I want to measure something else. Distance between these 2 points, let's say 1 and 2. Oh yeah, okay, it shows invalid because I need to close it. Or this is the vertex 3, let's say delete, or we'll close this thing first. Okay, and click outside. Again we'll measure. When I measure it again, what happens is, look, from this point to this point, 87 distance. Close it. I'll make a mistake again. It shows the distance again. Close it, click outside, measure this point, look, 37 millimeters. That's alright. This is distance between 2 points. Okay, now only one thing, close it, point outside. The good thing is it shows about also single point. Look, when you click only one point, it shows X, Y and Z. Now what it shows is x is 71, y is minus 64, and z is 37 millimeter. So this distance is compared with the origin, so everything is based with the origin. It's a kind of positioning system. X is 71, so from the origin x is 71, this is x, and y is minus 64. This will be x, this will be y. So from the origin, so when you look closely, this is the origin, this is the point. From here to here it shows x, so from here to this line will be 71, and in z we'll see from this point to the upper point, which is this is z. From this point to up it is 37, and y is negative because from this point y goes up, but this is on the downside. When it is on the downside, it shows negative 64. So it's correct, this is definitely from the origin. Okay, so it shows distance between points. Now we'll close this, and also we are going to do again measure, and it shows, look, from this line to this, look, it shows the distance between two lines 87.78. Close, measure, distance between two lines is like from this point to this point, bottom. Look, it shows the distance is 144, but look very closely, it also shows dx and dz. Look, if you used to measure from we cannot measure using smart dimensions, or even if we measure, we cannot get the dx and dy, in just a click. We need to again measure this, and we'll come to know. But here it's, this measuring tool is very good. Like if it is placed at an angle, then this becomes the dz, dx, and this becomes the dz. There should also be dy, which is 0 in this case. So you're getting me how the dx and dy is being made. If you look closely, this is dx because this x goes here, this is the x, so this is dx. The z goes on the top, that is where it is dz, and the y goes over there, but there is no point over there. If we select this point and this point, then it will show y, but only from top to bottom, then it won't show y, so dy is 0. So I will show you the point, I will show you the dx, dy, dz, measure and point, this point and the last point, this thing. Look over here, click. Now you're getting me. Look, the distance is 169. Now dx is 139, dy and dz. So look over here how the dx goes, the origin, check the origin on the right. So here dx is 139, the z goes on the top, which is dz is 37, and one more dy we have, because from the origin, from here to here it measures, which is 87, dy is 87, not here to here, this green line is dy. Okay, keep in mind, not here to here, not from the origin, because my points are placed on the extremities, on the vertex, on the far ends. That's why it shows this line and not the origin. So it has nothing to do with the origin, thus origin gives us the direction. So this green line, red line and blue line will be dy, dz and dx accordingly. So this was, and it is not restricted only to points and lines. I'll show you. When you click the surfaces, look, just on one surface it shows the area and the perimeter. You know how great the tool is. What is the perimeter and what is the area? Definitely this is the surface area. Okay, so this point and this point. Again, it shows the distance, very simple, 37. And here you will get some more idea about like the two selected items are parallel. Okay, now the evaluation is done that this is parallel. Yes, because there are many parts in which you need to do these things, complicated parts especially. So whether it's parallel or not, we'll come to know. The normal distance is 37, and delta x, delta y, delta z, far more into depth. The total area of both the green marks is this. So this was about the surfaces. Now let's say whether this surface and this surface, the two selectors are perpendicular to each other. The selected items intersect. Wow, great information is superb, and engineer definitely can give such type of informations. So this is cool. One more area. Look, it shows the total area. Now it is difficult to analyze between three objects. This is fourth one. As you increase the face, this thing gets increases. So nevertheless, it's superb. It's great. Close it, this thing, and when you measure it, it also shows in inches. If you were to change it, and this is for circular measurement. So this was everything about the measurements, and you can see this is a kind of positioning measurement, like when you measure it with the help of the points or lines. And positioning measurements or positioning constraints or something like, everything is linked up with the origin. So wherever your path is, wherever your point is on the path, the distance will be always measured, somehow, in this sense, with the help of origin. So whether you're working in automotive assembly, automotive manufacturers, and you're making a door panel, then there's a big door, and then you're working on a part, and you're placing your point, then it definitely shows from the origin. Doesn't matter where the origin is. If your origin is this, and you're working here, if the distance is large, definitely it would be a little bit difficult, but yes, it will be the positioning constraints only from the origin. In this case, origin is here, but yes, definitely everything is from origin. So that was regarding the measure tool. So now, after the tool measure, we are going to use another tool which is called the mass properties. So this is something more than the measure tool. Measure tool used to measure, but mass properties used to give the complete information about the part. I'll show you how. Go to mass properties, and yes, everything is done. Nothing to do anything, just you need to check. We'll show you. This is mass properties, and this is the density. First of all, like, what is the density? Density is 0 because we have not specified the material, so density is 0. But yes, definitely it shows the mass. Okay, the mass is 453 grams, and the surface area in square millimeters. The center of the mass, where is the center of the mass, xyz, and the principal axis of inertia. Well, I'm not going to teach you mathematics, that's why I won't be explaining you regarding the principal axis, the moment of inertia, and the different iz and ix and iy, all those things. But yes, definitely I will give an information like what's the mass and volume changes. So remember, the mass is 453 grams. We'll close this thing and we'll specify the material. Right click, and I will select 1060 alloy. Okay, this is now 1060 alloy, and remember weight was 453 grams. Okay, again the mass properties. Look, the weight is increased 12243 grams, and the volume and surface area have changed. Well, the density remains the same. Let's check with another material what happens with the density. The mass is 124. Okay, close this thing. Rubber. This is rubber part, and then mass properties. Still the density is 0, but yes, this decreases 453. So no effect on the density. Might be density are not calculated with the material already available, but yes, that can be done. That's not a big job. And what I need to let you know is, like, when you click the mass properties, you will get everything in, look, millimeters, because I have specified the millimeters and grams and everything. I want to change, I don't want in millimeters. Then, as I showed you in earlier tutorials, like tools, and then you need to go to, options. So I'll find where are my options. These are my options. And then document properties. And when you go to units, this is custom. I want to make it to IPS, which is the inch, pound and second. Okay, I'll make it okay. So this is now in inch, pound and second. Mass properties, look, cubic inch, this is 1 pound, cubic inch. So in this way you can really check what is happening. And the main thing about this tool is not only to find out, but also to keep a control. What is a control? Like, when you're making a part and you want to make that part in which should always be uh, equal to or less than 1 pound, then yes, this material is suitable. Although rubber, forget about rubber, but although what you do is, like, when it goes more than one, for example, this is a steel part, and if it goes cast iron or anything, if it goes more than one, then you start decreasing the dimensions, and it should not affect your assembly or the mating connections or anything. Or you make the part hollow, or you make some slots in order to reduce the weight, or you modify the part, you modify the material, whatever you do, but your constraint is this, like, it should not go less than 1 pound, or it should be less than 1 pound, but it should not go more than 1 pound. So if you're fixing a constraint and then you're changing your materials, you're changing your part, or modifying, every time you check it with mass properties, every time, and you get your answer, yes, now it is done, this is okay, and then you are done. So for keeping a control, this will be necessary. So here, in this way, the mass properties will be really helpful to evaluate your mass. Okay, so now I'll be changing the material. I don't want this material. Right click, and then I'll select anything like ABS PC. Now this is transparent cast alloy steel. Okay, this is good for me. And after the two tools, I will go to another tool, which is the statistics. So this is the statistics. Now what it does, like, what is statistics? So this tool always deals with, as you can as the name says, it deals with some kind of calculations. Always statistics, always calculations, lot of calculations. So what are statistics? Just click it, you'll understand. Look, here it showed some calculations, like this is part 1, features 2. There are 2 features in this part. Solids 1, it's a complete piece of block. Solid 1, there are no surfaces, which is 0. The total rebuild time in seconds. So for making this part, it is taking only 2 seconds. And what are the 2 features? As you can see, first is sketch. It is not feature like what you did it, you made a sketch and you extruded deposit, that's it. So there are 2 things. So in order to make it interesting, I'll change some of the features. Let's see, there are only 2 things now, remember. Now what I'll be doing is, like, you go to sketch and click here. This is how I need to do something and make it it's a bit more. Everything is in inches right now. 20 is still big. I'll change the tools, options, document properties, units. I don't want inches, I want it in millimeter, gram second. Okay, make it okay, and then edit feature, the 500. I want it 20, or say 50, sorry, this is 50. Okay, and what I'll be doing is sketch, and here I'll make a pocket or extruded cut, and that will be through. Okay, and I'll be making some fillets here, some fillets here, some fillets here, and some fillets here. Okay, so now everything is having fillets, extrusion, extrude cut. Now what we need to do is only go to evaluate, and after going here just select the statistics. Look, now it shows there are 7 features. Okay, and there is one solid, and surface is 0, definitely only one is a single part, and total rebuild time in seconds is 0.14 seconds. So it takes 14 seconds to build this part, for the computer to take 14 seconds, not for us. Like I take 1 hour to extrude it, but how much time it will take for my computer to, when I click on the, like after making a sketch I click on the extrude button, how much time the computer take is, this is the computer taking time, not my time. And you can see here in fillet it takes maximum of 66% of my time, and boss extrude takes 11%. This is all 11%, and 0% sketch doesn't take some time, and this is the time in percent, and this is the time in seconds. So why statistics is necessary? Like you're working on an assembly or a part which are having almost say 40 features, 50 features, and then you say it takes a lot of time for a computer. So from these statistics you can really decide, like if this fillet is taking 66% of my time, and it varies from computer to computer, you need to have a very good computer for this time to be say just 20 seconds or just 5 seconds. And yes, definitely if this thing varies, if I'm making my part in my computer and I find out okay this is taking much more time, then what I'll do is skip this part, skip this feature. So instead of this feature I can do something else, and then it will save my computer time. Not only saving the computer time, but for making this feature, every time you work on something you don't like it, you change it, and it takes a hell of. So you can see this is only 7 features, only the 7 things, but if you're making a big assembly it will be 50, 60, 70. And one more thing, like if you're making a very complicated assembly with a lot of features, you can just go to statistics and check, like, oh, I made 500 features in a part, or I made 1000 features. So it's a question of your pride. Definitely, definitely, but this will give a lot more of information on your part, and it's only necessary on the advanced level, not on the beginners level. So this was about part statistics. So now a new feature called the deviation analysis is there here. And what is the deviation analysis? Like, just click it over here. I personally don't use this tool many times, but yes, for you to make, I want to make you understand, and let's see how it works. Like, is a click here. When you click here, calculate, look, it shows some arrows, some 2 arrows in 90-degree, and it shows there are some degrees. So what are these degrees? These are degrees of the edges. Like the edge is placed on a 90-degree, like if there are 2 surfaces, both the surfaces are making an angle of 90-degree, so this edge is on the 90-degree angle, and it shows like the variations. The green, this is the 90-degree, 90.02, and the variation is the blue, the last one is 89.98. so almost both are very close to 90, and this red means its average size. So this is on the 90-degree edges, and also click here and again calculate. Again it shows, look, the minimum deviation is 90-degree, same like the red and blue, red and the blue, and it shows the calculate option. And now what I'll be letting you know is regarding this the curved one. Let's see what happens with the curved one. we'll delete this thing, delete delete, and then I'll select this curved edge. I'll select curve and then calculate. When you calculate, look, there are lots and lots of what do you call uh, this arrows. So I want to make these arrows a bit less, so for that I'll reduce this size and then calculate. Okay, now I can see the arrows clearly. Again, it shows that this edge is also on a 90 degree, although there is a radius over here, but the radius is from this point. But if you talk only about the edges and the this single points on the edges, definitely if both the things are 90 degree, then it shows this is 90 degree in this case. But if you select this edge, it won't be 90 degree. You know why? You need to understand that thing, because this edge is placed, look, this goes like this, and this goes like this, the surface I'm talking about, left hand side and vertical. So this is on the 90 degree one. But if you select this edge, okay, this edge, where are the two surfaces? This is going down somewhere and this is straight, so one will be 90 and one will be calculate. Look, you understand? Look, it shows only one arrows, and one arrows, like, I'll delete this edge first and again calculate with this edge. Now what it shows is, it shows 0 degrees, you know, because it shows 0 degrees because you can see the X but you cannot see the Y. I mean, there are no surfaces in Y on which the edge is placed, so only 0 to 0.04. so this is on the 0 edge. Again, if you select a line, oh yeah, this is edge, but if you select this line, this will be 90 degree. We'll select this line this time and calculate. Look, again this shows 0 because this is a single surface and there are no two surfaces over here. Again, this edge will select, it will be 0. Look, this is also 0. I want more number of this thing, this is the thing. And but what if it's a curvature? It's a kind of, we'll see. We'll delete this thing first, delete over here somewhere, calculate. Look, it is also 0. Smaller, I want smaller. Oh, I want more. Calculate. This is very more, lot of, this is medium size. Again, I will be calculating, delete, click here, delete. I don't want this edge. Let's say close this thing, and if you talk about this feature, delete. I don't want this feature. Yes. Okay, I want fillet, but I want that fillet to be here, fillet, and here. Okay, because I wanted this line. So evaluate, sorry, double click, and then after evaluate deviation, let's see what happens with this line. Calculate. Look, now I'll show you what is happening. It shows like it starts from 0, the blue one, and it ends up in 90 degree. So as you can clearly see, the point over here is placed on the two 90 degree surfaces. But as you go down, this 90 degrees is to 45 in the middle, and then the pink one to the 22 and the 0. So what is 0 now? 0 is definitely on the flat surface. Forget about the flat, forget about the 90. Now concentrate only on the 45 degree. 45 degree is, so the two surfaces which are very close to this fillet is like, this is 45 degree with this. Well, I don't use this thing, but you will get an idea. Now if I want to edit the color, and I will select, I want to select a color which is uh, which is called black, which is a black. Okay, then when you calculate, it shows black for the maximum. You can select the minimum and maximum colors. Like this, the black is this, and edit color this. I want it white. This is white. Okay, and this point will be white. Calculate. Look, this is turned white. So this depends. Like this is my minimum, this is my maximum. So this is how you calculate the edges, the lines, and whether it is with the uh, under certain limits. If you want this varies under certain limits, or you want whether you want to check whether what the deviation is, then you can check the angles from your. I don't use, as I said earlier, but yes, it is useful sometimes. And this concludes our tutorial of deviation analysis. Now we are having still more number of uh, evaluation tools which will be covered in the later topics, but for now in this session it was measure, mass properties, statistics, and deviation analysis.